A nuclear reactor works by splitting up atoms such as uranium. This is known as nuclear fission. These large atoms are very unstable and can be split up by firing a neutron at them. They split into smaller atoms and a number of neutrons. If we measure the mass of the initial atom and the total mass of the products after the split, there it seems to be a discrepancy. Some mass seems to be lost. Einstein's famous equation E is equals to mc square shows that this incredibly small amount of lost mass is converted into a huge amount of heat energy. So we know that each atom splitting up gives off some heat energy. But it gets really exciting when you put a bunch of these atoms together. As one atom splits up, it releases some energetic neutrons ready to split up some more atoms, which in turn release more energetic neutrons, which will split up with some more atoms and on and on. This is known as a chain reaction. The problem is, if we don't control this reaction, we soon end up with an incredible amount of heat energy, which is impossible to control, resulting in what is known as a nuclear meltdown, which isn't very useful when you're trying to run a power station. To control the rate of reaction, we need a substance which can absorb the neutrons, stopping them from splitting up other atoms in a nuclear reactor. This is done by control rods. When lowered, these control rods stop the reaction if necessary. They are built and positioned in a way that they ensure the drop into the fuel in case of any emergency such as power cut. During normal operation, they are raised and lowered accordingly to vary power output. The lower they are, the lower the rate of reaction, which means a smaller output. The higher they are, the higher the rate of reaction, which means a greater output. With the aid of control rods and other design features, nuclear reactions can be regulated, meaning there is a constant production of manageable heat energy, which then can be used to heat water into pressurized steam. This is then used to turn turbines, connected to a generator producing large amounts of electrical energy. Nuclear reactions can release a lot of energy, which can be very dangerous. But because of ever-growing hunger for energy, scientists are working very hard to make this technology safer and potentially reducing the use of the fossil fuels. Hello guys, it has come to my notice that only 64.5% you are watching are subscribed and 35.5% are not. So kindly subscribe to my channel. I would like it a lot. Thank you and have a nice day ahead.